All right, guys, so first I want to take just a minute to go through this question which was on the quiz. Now, I know a lot of people had a hard time with this question. I was going to go through it through class, and you guys were doing such a great job working on related rates last class that I completely forgot about it. So hopefully I'm able to put this in time and you'll be able to look at it before your celebration tomorrow. The big part of this is recognizing what is it when we have a normal. A normal is just a line that is perpendicular. And secondly, you have to recognize that there is more than one point at which you're going to get a normal. All right. So first, let me kind of give you a quick visual. All right. So let's get a picture of what's going on. All right. So this is my problem right here, in which I have an equation. Okay. Now this is not the right equation. That's not the point. The point right now is that we're trying to visualize what's going on here. So we got some type of equation. I've drawn a quadratic here, whatever. Okay. It says determine the coordinates of the 4 points on C. So there are 4 points on this curve, whether it's a parabola or some other shape, at which the normal passes through the point 1, 0. So here's 1, 0 right here. Okay. The normal to the graph of C is this line right here. See how it's perpendicular right there? Okay, so it's perpendicular right here when it crosses C. It's going through 1, 0. That's what it's asking for. But it says that there are 4 locations when this happens. Okay, now this one right here is pretty easy to see. If I were to draw one kind of over on this side, you'd see another point over here where it kind of intersects right there. And that would be another normal to the line of C that goes through 1, 0. But the thing is, I need to find all of the points where that occurs. Okay? Now, many of you did something really good, which is that you started with finding the derivative. All right? So, yes, the first thing you're going to do here is find the derivative because you know for a normal graph, you need to find the derivative. And so I'm going to go ahead and kind of move this over to the side. You got the idea of what it needs to look like now. Here, I'm going to throw in, here's what your derivative should look like, right? That's 4x. You're taking the derivative with respect to x, then you do the y squared, which is 2y dy dx. Please don't forget the chain rule. Since we're doing the derivative with respect to x, then that means that we need to do the chain rule there with y. And then, of course, it's equal to 0 because the derivative of 18 is 0. Now, once we have that, then we're ready to continue solving the problem. The next step is that we need to solve for dy dx. All right? So I'm going to get dy dx all by itself, and you should get something like this right here, that dy dx equals negative 2x over y. Now, at this point, what you're going to do is we're going to write an equation for the normal that goes through 1, 0, and also through this point right here. Now, in order for it to go through this point right here, I'm going to call this point A, B. You see I've already kind of labeled it on my picture. It needs to be some kind of point A, B, because x and y in our formula are going to be different from A and B. A and B is a specific location, whereas x and y are variables that can still represent anything. All right? So now I need to write an equation, all right, using the values that I have. And so my equation should look something like this. Okay, now this is point slope. All right, so it's y minus y1 equals the slope times x minus x1. You'll notice that what we've done here is we've put in a point, a comma b, because we're saying that the normal line here has to go through AB. And the other thing we're saying is that the slope needs to be normal to C, or it needs to be perpendicular to C. Now at AB, the slope is, well, if you put AB in here, it's negative 2A over B, right? So that would be the slope. But the normal is the reciprocal and the negative of that. And so we would flip it upside down, and it would become B over 2A. All right? So hopefully you got that kind of idea down. We've written this equation now. Y minus Y1 equals m, the slope, which is the perpendicular of this, times x minus x1. Now, at this point, you actually know a second point that it goes through, which is 1, 0. Okay, so you can go ahead and substitute 1 comma 0 into that function, and you should, once you put in 1 comma 0, you should be able to get to a certain point where you can solve for a and b. Now, if you can't solve for it yet, okay, because you're having a difficult time with the mathematics or whatever, you can also write a second equation, right? We can write a second equation using our original function up here, right? 2x squared plus y squared equals 18. Because we know that AB has to be on that line C as well. And so you put A and B in there, all right? So we put A and B, so we'd have 2a squared plus b squared equals 18. So between that and then this one right here, where we have 0 from our point, 0 minus b equals b over 2a times 1 minus a, then you should have two equations, two unknowns. Okay, I'm not going to do that math for you. I'll leave that math up to you. But with those two equations, two unknowns, you should then be able to solve for A and B. Okay, now once you do that, you should get that B is 0 and A is -1. Now, at this point, now that you have 0 and -1, you have to actually take those and plug them into your original formula of 2x squared plus y squared equals 18. You'll notice that when we make b, the y value 0, I'm going to get 2x squared equals 18. Solve for x, you should get a positive number and a negative number. Same thing when I put a equals -1 in for x, because that's my x value over here. I should get a number plus y squared equals 18. Again, I'm going to get a positive and a negative. Okay, so once I have that, then I should be able to find the final solution, which are the 4 points. And your 4 points should be this right here. And that will be your answer, that it's going through those 4 points. All right? So, again, the key was we knew we needed an equation for the normal. In order to find an equation for the normal, I need to know what the slope is so I can find what the perpendicular to the slope is. So first we do the derivative. Once we have the derivative, we solve for the derivative, dy dx, and we get that. We write an equation with the perpendicular slope, which is negative and then reciprocal. Once we have that slope, which would be b over 2a, we put it into point slope, which is y minus y1 equals m times x minus x1. Once we have that, we can substitute our point, which it needs, the normal needs to go through 1 comma 0. So you can put a 1 in for x, put a 0 in for y. At that point, if you're able to solve, wonderful. If not, then you can go ahead back to your original function and put in a and b for x squared and y squared, because that point needs to be on this curve of c as well, which is what this equation is right here. Once you have a and b in there, you have a and b here, you've got two variables, two equations. You should be able to solve for a and b. This is the value you get for b. This is the value you get for a. So as long as a is -1, then it doesn't matter. You can solve for b. b, you'll get 4 and -4. If b is 0, then you will get 3 and -3 for a. Again, that's from taking these values and putting it into the original function, because ab, again, needs to be in that original function. All right? So hopefully that was helpful for you. There's one other question in here that asks for a normal. It's basically the same idea. All right? So that's all for tonight. Hope that's helpful. Later, guys. Good luck tomorrow.